Okay, welcome to another video. We're going to talk about integration by u-substitution. First of all, what is u-substitution and why do you need it? Well, most integrals can't be evaluated by inspection or using the elementary methods that they teach you in calculus right away. And a substitution, what that does for us is it transforms a hard-to-evaluate integral into one we can do using basic formulas. The key is to look for the presence of the derivative of a function in the integrand, and we'll explain what that means with an example. Okay, here's our first example. We want to evaluate the integral of x e to the 2x squared dx. Now if you're just starting out with calculus, you probably don't know how to do that. So let's start with writing down what we do know. And the trick is we're going to make a change of variables, transform that integral into something we already know. So we already know that the integral of e to the x dx is e to the x plus c. So the trick is to get the integral we want to evaluate into this form. So let's look at the integral again. Now we got two problems. First is the x here. And then we've also got this 2x squared up here. So let's look at the problem of the argument, which is the 2x squared. We know how to do just e to the x, or e to the y, or whatever, so let's try to get it in that form. So we're going to do a change of variable. We're going to introduce a new variable u, so that we can transform 2x squared goes to u. So that e to the 2x squared is e to the u. So the integral would transform something like this. Integral of x e to the 2x squared dx would transform into integral e to the u du, which we know how to do using the basic formulas. It's just e to the u plus c. Okay, so let's do the change of variable. Take u equals 2x squared. But we've got to worry about the differential too, which is dx in the integrand. If we're going to change variables, we need to change that also. So let's go ahead and find the derivative of both sides of our change of variable equation. So we start with u equals 2x squared, and all we're going to do is take the derivative of both sides, and technically it's a differential. So we've got du is d of 2x squared is 4x times dx. So all we did was we took the derivative of x squared, which is 2x, constant doesn't matter, we pull it out. And since it's a differential, we tack on the dx at the end. Alright, so let's go back to the integral again. So we've got integral of x e to the 2x squared dx. So the argument to the exponential, 2x squared, we said that's going to be u. And now we figured out that du is 4x dx. In other words, we can write the differential of the old variable x in terms of the new variable u. So x dx is equal to 1/4 du. Together with u equals 2x squared, we can write the integral in the standard form that we want. So the integral of x e to the 2x squared dx is equal to 1/4 e to the u du is 1/4 e to the u plus c. Now all we did there was we changed 2x squared to u, and then we changed x times dx to 1/4 du. Now to get the answer we seek, we've got to transform back to the original variable. So we take u equals 2x squared and transform back. So the 1/4 e to the u plus c is just 1/4 e to the 2x squared plus c. Okay, let's try another example. We're going to evaluate the integral of x squared plus 1 over x cubed plus 3x times dx. Now, at first glance, this might not be so obvious how you would approach it. But notice the expression in the numerator is almost a derivative of the expression in the denominator. So what we'll try is we're going to do a change of variable, and we've got u is x cubed plus 3x. So we'll take the derivative of that. Du dx equals d dx of x cubed plus 3x is 3x squared plus 3. And so du is 3 times x squared plus 1 dx. So in other words, x squared plus 1 dx is 1/3 du. Therefore, our integral of x squared plus 1 divided by x cubed plus 3x dx can be written as 1/3 integral of 1 over u du. And that's a simple integral we know how to do because the integral of 1 over x dx is just natural log of x plus c. So, using our transform, or change of variable, we found that the integral of x squared plus 1 over x cubed plus 3x is 1/3 the integral of 1 over u is 1/3 natural log of u plus c. So now we got to change variables back again. So using u as x cubed plus 3x, we obtain the final result. That's integral of x squared plus 1 over x cubed plus 3x dx is 1/3 log of u plus c is 1/3 log of x cubed plus 3x plus c. Alright, for the last example, we're going to take an integral involving a trigonometric function. So we've got the integral of x squared cosine of 5x cubed dx. Now the derivative of x cubed is 3x squared. So you notice that we almost have the derivative in the integrand because we've already got the x squared there. And we also know that the integral of cosine of x is just sine x plus c. So let's try u equals 5x cubed. Taking the derivative, du dx is d dx of 5x cubed is 15x squared. So 1/15 du equals x squared dx. Let's rewrite our integral using that knowledge. Integral of x squared cosine 5x cubed dx equals 1/15 integral of cosine u du is 1/15 sine of u plus c. And all we did there was plug in our u equals 5x cubed. Now we back substitute in terms of the original variable, and we get that the integral of x squared cosine of 5x cubed dx is 1/15 sine of 5x cubed plus c. Well, hopefully this video has helped you with u-Substitution. For more information on calculus, go to calculuswithoutlimits.com. We have a book that covers calculus 1 and 2, solves a lot of problems in step-by-step